Welcome back to my YouTube channel. Today we are going to learn some concept about the networking part. In last video, we have talked about something networking, like we have bridge connectors, the networking part, and today we are going to more deep down into the networking and how the inspects on the bridge networks. We have different connectivity parts. In the last class, I have just given the overviews and some important things which will be going to use in this video. So if anyone has not watched that particular video or day 4, so please go watch that video, and this is the previous video you need to requisite. Okay, so now let me quickly start with the things, and let me show you that some commands. So I have just launched my machine also. So let me quickly go inside the root, and some docker my docker is running. So let's quickly check with systemctl status of docker. All right, so yeah, our docker is running, and let me quickly check with the what all the network we have. Docker network, and we provided the ls. All right, so we have three types of networks. First is bridge, second one is host, and another is null network. All right, so we are going to look into this the network. Let me quickly inspect right now with the bridge. What the bridge network is all about, we are going to learn more into that. So let's, so we have docker network inspect bridge. All right, so when we do the bridge, so we get the subnets. In this subnets, our docker is running in this gateway. This gateway is using. So the bridge is the name of the network of the setup. Basically, what's happened? Let me quickly show you with some. All right. So what's happened? We are seeing the docker network concept. All right. So what generally happens, Docker creates a non-physical network setup called Docker LAN. We have a Docker LAN, or it's like we have multiple containers running, and if you want, if we want to, all both can connect and with each other and have a connectivity. So we use Docker LAN for the this things part. So Docker creates a non-physical network setups called Docker LAN, and using software defined network devices, like we have something as DNs, like type of software, it's generally known as software defined networks. Alright, this is a service, like we have virtual wire, switches, router. So let me quickly show you with one quick diagram. Alright, so we have one container name as my OS1 and another container as my OS2. Okay, and we need to connect, and so that if sudden traffic comes, we have multiple load balancing part, as already you guys know load balancing and auto scaling parts. So this is running on the IP 172.17.0.0, and this is again running on IP 172.03. All right, 02 and 03. These both are running. Now we have a switch from which it gives a path, and we have a router, or you can say a gateway type of work. It also works as a gateway part. So we have a whole box, and in this box, this our two containers are running. Here the switch is there, and the routers are there. We have router, or we can say gateway. From this, external person or the client comes and hit your URL. Through this, router helps into getting the, like if this IP is available, so it's hit on this. If this IP is busy, if this IP is available, so it can be hit on it. So we have here DSCP, or we can say IPAM. IPAM nothing but IP address management. Okay, it's a method of taking care of assigning IPs to all the container in one network setup. It's like what's happened. We have a general different containers, and everyone running on each IP. So this IPAM, it's nothing but IP address management. Let me quickly write over here for your IP address management. Alright, so this is the like method. It's an quick method for taking care, like for assigning the all IPs of the container in the one network. We like it's creates a whole one network. We have different containers running, and it's totally creates a one network. Alright, so like for example, the subnets of the like the network setup is, if we see here, in the subnet we have these subnets. All right, 172 root.17.0.0.0/16. From here, like different IPs are getting used, and we can use those particular IPs. All right, here from in that subnet we have 16 IPs there, so we can launch by 0 1, then we can go with 0 2 0 3 0 4, like this we can launch different containers that particular subnet or in that particular IP, so it will be easily accessible in that particular our own network setup. Alright, so if the first IP is reserved as a network as the name, and so let me quickly show you. Alright, so what going to explain you about the first IP. The first IP we have like 172.17.0.0. So this is a reserved IP as a network name. Like what the network name have, this is a reserved IP for the network, and the last IP 172.17.255, as all are familiar with the networking concept, I think. Otherwise I will be creating one videos for this networking concept too. Alright, so this is the reserved IP for some other broadcasting, hence all the IPs will be arranged between these two. If we are launching any container, so it gonna launch container between this IP only. Like if the container launch, so it can be like one giving IP this IP, or you can, or some another container launch, it can provide with the IP 8 IP. So the IPs will be provided in between this two range only. It will not go either this part nor either this part, and they will not assign this IP to, because these are the reserved IP. This is for the network name, and this is for the broadcasting part. Alright, so one more thing is there. The IP 172.17.0.1, it is reserved for the router. Okay, this IP is reserved for the router part. Router works on this particular IP, or what is your subnet started. 0 is reserved for network name, 1 state for the router part. So let me quickly show you. We like C route -n. Okay, so see, this IP is reserved for our for the network routing all those parts. All right, so coming to the next part, whenever a new container is added to a network, it automatically connects to the Docker lane and using virtual wires, hence allowing it to networks with the outer world. Like from the Docker lane, it connects by, suppose we have launched one new container. All right, so let me quickly launch docker run -it -name by my web OS 7. Alright, and using the CentOS image 7. So whenever we have launched this IP, whenever we have launched this container, so what's happening, it automatically connected to the Docker LAN using the virtual wires, and it allows like to connect with the outer world. Like we can connect from the outside world, all this part. By how we can get? By the Docker lane. We have a concept as Docker lane. I already explained you. We have a concept of Docker lane. Through the Docker lane, it can be happen. So if you want to check the connectivity with the Google, so we have a command like ping 8888. Alright. So as you hit enter, it start pinging with the Google, like, yeah, we have a connectivity issue. If it's not working, like it shows like there's some network issue. If it's working, like, yeah, pinging with the Google. Alright, so however the Docker network is isolation network, since only SNAT is enables, only Docker can connect from outside world. So certainly what's happened, let me, yeah, so what's happened, Docker, it's that Docker network, it's an isolated network. Like isolated means no one can access from outside. Okay, we have some isolated part. So this isolated part is there, so only SNAT is available. SNAT is there. Okay, so SNAT is only available, enabled here. So by this only the Docker can connect to any outside network. Like we can't connect from the outside network to the Docker, but Docker can connect to the outside world by the SNAT part, because SNAT is only enabled here. So for the outside network to connect with the Docker, so we need the DNAT to be enabled over here. All right, you get the terms what I am explaining about. Okay, let me just quickly give you something a brief. What we are doing? If you want to access the things from the outside world, we require DNAT. DNAT should be enabled, or if we want Docker should connect to the outside world, so SNAT should be available. So these are the two parts which should be which are used in the Docker networking part if you want to connect from the outside world. All right. So let me quickly show you with one more thing. This is the diagram where we have bridge, we have none. These are the three networks. All right, these are the three networks. All right, these are the first is bridge network, another is none network, and third is host network. So what all these things, like we run like Docker run hyphen we provide the name, we provide with the port, we, so all this comes from the bridge network. It's creating a bridge. We have a, see, you can see over here we have a Docker, and multiple containers are connected with one like on in the center part. But in the none part, we don't provide a network to the Docker. It like only a single on in the host, like only a single container is running. And if you talk about the host part, we generally host on particular IPs, like exposing it on the port 5000. We want to connect from the outside world single container. So these are the three networks which provided by the Docker's part. All right. So coming to the next part, let me just show you. Ah, so now the what is the next part? We are going to launch see a quick demo here. All right. If you want to, let me just, it's an practical, or I can say it will be a quite interesting demo for us. Suppose if we want to see a web server we launch from the inside the base OS, so there is a general command we install, like yum install httpd. Httpd is generally web server provided by the Apache. So we are quickly installing our web server. Okay, we are installing the software like httpd. Now we are going to create some web pages. The web pages are created in cd/var/html. As you enter, we don't have a certain file, so let me quickly create a file, index.html. So hello, this is demo. Alright, so we have created file. If you want to check index.html, you can check by this too. Hello, this is demo. If you want to do ls, yes, file is created successfully. This is one of the command through which you can create a file, or you can just this can't create this, take the input from particular all those files. So as our services be started, let me quickly show you this on the web server. Index.html. I think it's gonna take some time. Alright, so what we need to do, we need to first of all allow all security bonds, inbounds rules. So they are the security parts. Why this inbound rule? Because as I already explained, we need a DNATing and a SNATing part. So I'm just allowing inbound rules, like, so I can access, anyone can access from outside world to inside world. Like right now the things can't be accessible. All right, so let me quickly modify with the some security groups. Just I'm going with the all traffic, like anyone can access this public IP, and let me quickly save the rules. Okay, so we have seen the rules has been saved, and let me quickly restart our services. Systemctl start httpd. Alright, so our service has been started. Let me quickly relaunch our server. So yeah, our service has been running. First of all, the service was not running, and now the service has been started. I think I need to restart the service. Okay, alright, there is some issue. I think I need to check. Alright, so the thing was been running over here. So your what's your demo? It's like how you can launch this into the Docker, and this will be one of the interesting projects. How you can launch web services into the Docker part. Alright, so that's it in the video. This is your one of the tasks. You can just take it as a task, and you can just see like how you can launch certain containers or into you can launch a web service in the container. So alright, so let me quickly show you. Take your time and just pause the video and just try by yourself. I'm just showing with a demo how you can create an image and run HTTP server inside your Docker. Alright, so so let me quickly show you the demo how you can launch a service in the Docker, and how you can expose and how can run a server inside a Docker using image. Alright, so let me quickly launch one container for you. Docker run hyphen it, uh, and let me show you one more thing. We have this IP, and let me quickly launch. Let me show you with the quick things. We have index.html, and we want to check with the things. Alright, so just copy and just open incognito, just paste and slash index.html. Alright, so our demo page is working fine. Alright, so you can just change and it can be the thing, but we want this thing to be running into the Docker part. So running this into the Docker, just quickly launch the Docker run hyphen it hyphen name web 4. Alright, and using the CentOS 7 image. So as we are inside the Docker, quickly install quickly install HTTP server hyphen with y, and our service has been running. Started. The HTTP web server is downloading. So let's wait for just few seconds. Yeah, the service has been completed. Quickly go to the as I shown of a web service file HTML. When you do ls, we don't have such file. Let's create quickly index.html, and hello, this is Docker inside web server. Anything you can write. Alright, so just hit enter and control C. Let me quickly check with the things. Is the file created? Or yeah, the file has been created, and just quickly check with the things. Let's install yum tools also. Yum install net tools. Alright, so we have installed the net tools also. Let me check with the if config. Alright, so if config is running on this, and let me quickly restart with the service systemctl. Let's check with the status. HTTP is what the status is all about. Systemctl failed to debug connections omitted. Okay. Here the systemd processes are running, or you can check with the ps-aux because we are inside the Docker. So yeah, can check, nothing as such of working right now. So what's happened when we launch a Docker, and when you start a service during the boot process, switch on kernel loads, which activates all your system devices. After this, kernel starts the first program called systemd. Okay, whenever you start with your container OS, the first kernel, let's start with systemd. So ps command shows the process ID running. Okay, so the systemd process also controls the systemctl. If we use ps-aux inside the Docker, as we are using ps-aux inside the Docker, so there is no systemd process running, hence the servers can't be started. So I'm just showing with the quick ways. Alright, so just check with the usr/bin/htpd, or as such no file directory they are just giving. So we have installed the nettools also. Let me quickly check with the netset hyphen tnlp. nothing, no services right now working. Alright, so the things are working, and just quickly exit from here and let me see the Docker, uh, Docker PS, yeah, Docker PS hyphen A. So this is our Docker we have just created 8 seconds ago, name as v4. So let me quickly commit this Docker so you all can use those particular images. Docker commit web4. Alright, so we are just committing with the web4 part, and we want into the new image like website image. Alright, with the version v1. So as we have what we have done, we have committed the things. Basically what we did, we first of all launched a Docker, and inside the Docker we have launched HTTP servers and created the files too. Now as we have committed this, this is a command to expose to. Now we need to run servers using images. So docker run hyphen dit, and with the port number I am using 1245. Anything you can use, it depends to us. Port number x80, and with the image name web6. Then we are using the our image. This is the name we have given, website image, with version v1, and using httpd, and with the force ground. All right. So as you hit enter, why it's failed, error response docker created. Alright, so my HTTP service is already running. I just need to delete. So let you can when you gonna run this command, it gonna run for you. Let me quickly just add. No, web6 is already running. So let me launch one more web4. So as you hit enter, our Docker has been running over here. If you want to check by netset-tnlp, um, okay, so netset-tnlp, we have given the port. Our Docker proxy is also running, and everything is running up to date. So the thing are all on the time. So this is one of the practical demo you can quickly do by yourself. It's one of the project you can do. So alright guys, that's it from my side. If you have any quick query, you can ask me, or let me do one thing. Let me just wait, I'm just alright, so what I have done quickly over here, I have just launched one more container with this port and with this command. Uh, just there was some mistake. This is the one of the command where I have just run docker run hyphen dit with this port 1245 is also already running, and with name as a web image. And if you want to check with the image docker ps, yeah, so about for 32 seconds we have up on the port 80 is transporting, and web 8 is running. So this is one of the cool demo, cool project you can use, and you can launch the docker, and inside the docker you can launch the web service as a http, and you can as you have committed, now you can also this push to the on the docker hub, docker repository, so everyone can use. Alright guys, that's it from myself in this video. We'll see more things of the docker in upcoming videos. If you have any quick queries, you can just ask me in the comment section. And if you please like the video, please share and subscribe. And if you have any quick query, you can just ask me in the comment section. Alright guys, thank you so much.